Hello students. In the last lecture we have derived the equations of motion. Now let's apply the equations of motion for a freely falling body. A body released near the surface of the earth is accelerated downward under the influence of force of gravity. In the absence of air resistance, all bodies fall with the same acceleration near the surface of earth. The motion of body falling towards the earth from a small height is called free fall. The acceleration with which a body falls is called acceleration due to gravity and is denoted by small g. Therefore, the equations of motion will become v is equals to u plus gt, s is equals to ut plus half gt square, and v square minus u square equals to 2gs. And if the body is released, that means in that case you have to take the velocity initial equals to 0 because the body is released from rest, right? And note that when a body falls freely under the action of gravity, its velocity increases and the value of g is taken as positive. And when the body is thrown vertically downward, its velocity decreases and the value of g is taken as negative, right? Or you can choose the sign conventions by using the motion in y direction, right? Or because it is coming downward, you can take it as minus y direction and you can use that sign conventions. Now, by using these equations of motion, plot the variation of acceleration with time, velocity with time, and distance with time, and match the curves obtained from the slide. Here are the tips to solve the kinematic equations. Firstly, you have to read the question statement very carefully. Then choose the origin. After that, choose the sign conventions. Now, you know what you have to find out, what is given to you. After that, take care whether the object is starting from rest, then that means you have to take initial velocity, in that case 0. After that, check the units of each and every term given to you. All of the units must be in the same system of units, either in SI system or in CGS system. Now, let's solve a numerical problem. The question is, a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters, and you have to find out the acceleration of the car. Now, the distance is given to you, 110, time is given to you, and because the car starts from rest, that means the initial velocity is 0, and you have to find out the acceleration. So firstly, check out of the three which equation of motion is applicable here. The second one is applicable, means d is equal to ut plus half at square. By putting all the values, you will get the acceleration, and that comes out to be 8.10 meter per second square. And in the slide, the star represents the multiplication. The next question statement is on the slide that a ball is thrown vertically upward with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. You have to find how high will the ball rise and how long will it be before the ball hits the ground. and it is given that you have to take the value of g equals to 10 meter per second square. If it is not given to you in the numerical problem, you may take it as 9.8 or 10, but write in your solution that you are taking the value of g, this one. Now, see the diagram. Here we have taken y-axis in the vertically upward direction with 0 at the ground. Now, V naught is 20 meter per second and the acceleration is minus g. So, it will be minus 10 meter per second square. We know V initially is 20, but the final velocity at the highest point will be 0. And let us suppose the ball rises to height y from the point of launch. Then that means I have the final velocity, I have initial velocity, and I have the displacement. So I will use v square minus u square is equals to 2as, and by putting all the values in this one, you will get y minus y naught equals to 20 meter. Now, there are two methods to solve this question. Let's discuss. In the first method, we will split the path in the two parts, upward and the downward. And for upward motion, find out the time first, and for downward motion, also calculate the time, and then you will calculate the total time. Right? For the highest point, you know that the velocity is 0 and we have to find out the time. So we will use equation first. That means v is equals to v naught plus 80. By putting it all the terms, we get the t1 time as 2 seconds. Similarly, by using second equation of motion, you can get the value of t2 as 3 seconds, and finally we will get the time as 5 seconds. Now let's discuss the second method. The total time here we have to calculate by noting the initial and final positions of the ball with respect to the origin chosen. Right? That means you have to use what? The second equation of motion, and that is y is equals to y naught plus v naught t plus half a t square. And by putting all the values, we get t is equals to 5 seconds. Here, I will suggest that the second method is better, since we don't have to worry about the path of the motion as the motion is under the constant acceleration. Now let's do another problem. A car moving along a straight highway with speed of 126 km per hour is brought to a stop within a distance of 200 meters. Now note that here the distance is in meter and the speed is given in kilometer per hour. So firstly you have to convert this kilometer per hour into meter per second. And you have to find what is the retardation of the car assumed uniform and how long does it take for the car to stop. Stop the slide or pause the video and try to solve the question yourself, and then match from the slide. By putting all the values, by using third equation of motion, you can get acceleration as negative sign, means it is retardation. And then by using first equation of motion, you can get the value of time, and that comes out to be 11.4 seconds. Now there are some questions. Try to solve these questions, and if you have some difficulty, then message your teacher to ask your doubt. Thank you.